What's going on, my fourth grade family? My name is Mr. J, and I want to make this quick topic 4 review video. Okay, now topic 4 was all about multiplying greater numbers, right? They're used to 2 by 1, 3 by 1. Now they're going to be multiplying 2 digits by 2 digits and 3 digits by 2 digits, right? And then in this topic, we go over all the different strategies on how to solve these multiplication problems, right? Back in the day, we were used to just standard algorithm, right? Just normal, multiplying, 3 digits by 1 digit, and we would just go down, right? Multiplying 2 times 0, 2 times 1, 2 times 3, and then if there is another digit here, then you would have to put the 0, and then multiply this 1 times 0, 1 times 1, and 1 times 3, right? And then you add them up, okay? This is the old school way. This is standard algorithm, which is taught also in this topic, okay? But additional to this strategy, we also learn how to use our place values, right? Our place values. We also learn how to use our base 10 blocks, right? How would we model a multiplication problem using our base 10 blocks. We also learn how to use grid paper, right? To use area models, right? To draw area models, right? We also learned another little strategy that a student helped me out, in which I'm going to share with you in a second, and then just normal area model, right? So I think I mentioned about maybe 4 or 5 there, but the ones that I really want to focus on is standard algorithm, which is what you see here. I want to focus on the area model. And I also want to focus on the place value, right? Learning how to use place value, how to use the value of a number that has zeros, right? Where you could take them out temporarily, do the multiplication, and then add them back to your product, okay? And there's another little strategy that I wanted to show them that might be able to help them with standard algorithm, okay? So let's go over first the place values, right? Place value, using in place values, right? So, okay, a lot of the teachers like to write their place values with that value's name, right? Or that number's value, but in word form. So you would see, like, let's say, for example, 2 tens, right? Times 4 tens, right? But I wanted to, and this is 20, right? Obviously, this is 20 times 40, okay? And this is using your place value and then putting the value of that, or the place value's name, right next to the number, right? So, and this is one way of writing it, and they are gonna see it on the test. But I guess when I say place value, I mean taking a number and breaking it into its place value. So let me show you what I mean right now. So let's say we have 74 times 56, right? Okay. 74 times 56, we're gonna break this 74 and 56 into their place values, right? So that value of the 7 is 70, the value of that 4 is 4. Okay, now you go and you break this 56 into its value, 50 and 6, right? So now, the 70 is gonna have a turn with the 50 and the 6. The 4 is gonna have a turn with the 50 and the 6, okay? And you could also combine this in drawing an area model. So right now, this is the first step, breaking each number into its place value. That's step number 1. Step number 2, you're gonna draw a box, which then creates 4 boxes, okay? Then, on the side, on this box, you're gonna label the 2 top positions here and the 2 side positions on the left here, okay? So let's use 70 and 4 on this side. Let's put it in red. 70 and 4, okay? And then 50 and 6 on the top. 50 and 6. Let's just erase these so we won't get confused. Okay. Now we have our area model drawn out with the value of each digit, right? So we have the value of 74 is a 70 and 4, 56, 50, and 6. Now what's gonna happen now is you're gonna figure out what multiplication equation am I multiplying or using or solving in this box. Okay, so this is the first box that we go to first. So I usually tell them, use your pencil. Use your pencil to tell you, okay, what two numbers is my pencil touching up and down and side to side. So first, let's do up and down. I'm in this box right now. I'm gonna go up and down. What number am I touching? 50. Side by side. You're in this box again. Side by side, what number am I touching? 70. So 50 times 70. Okay, and this is where you would use that zero strategy, right? Where you take out the zeros and put them back in. You take out the zeros. 5 times 7 is 35. Put the zeros back in there. You have 3,500. We just solved this one box. Now let's go to the second box. You could go either or, it doesn't really matter. But using your pencil strategy, right? I have my pencil in my box. Go up and down. What number am I touching? The 6. 6. Side to side. What number am I touching? The 70. So 6 times 70. Again, remove the 0. You multiply 6 times 7. This is 42. Add the 0 again. We have 420. Okay? So that's 420, 3,500. Now, and then we're just going to go through all the boxes. So let's just do this real quick. This is 50 times 4, right? 50. And then now I'm in the bottom. Now side by side, but on the bottom, 4. This is 20, right? I took out the 0, put it back on, 200. Now I'm in this box, up and down, touching 6, side by side, touching 4. Okay, this is 24. Now I figured out all my partial products. These in green are called my partial products because they're part of my full answer. Once I put all those partial products together, then I could get my full product on the bottom. Okay, so let's go and put these together. So my last step would be to add them. So the first step was breaking my two digits or my two numbers into my place values. Then my second step is drawing out my box, right? And labeling it. That's my second step. Always using the left side of the box and the top side of the box. Never use the side on this side. Don't use this bottom part. You can, but we're not going to do that. We're just going to stick with what we learned, right? So we're going to use this side on the left, the top. That's step number 2, okay? Step number 3 is solving each box using that pencil method I was teaching you, okay? Up and down, you're in a box. You got to make sure you locate the box. Up and down, side by side. Up and down, side by side. Up and down, side by side. And you're going to see which number am I touching when I go up. And when I mean numbers, I mean these on the top. Whichever the pencil is touching from these 4 numbers, that's the number that belongs in that box, okay? We're going to solve each. That's step number 3. Number 4 is always going to be the last step, and they all know this. When I say what's the last step, they all know that they need to add these up. So we're just going to add these up. Again, keeping in mind, and I always tell them this too, always try to line up your numbers as best as you can, one on top of the other, okay? Make sure that you put those numbers where they belong, in the place value that belongs, right? This is 3,500, so that 3 needs to be in the thousands place, 5 in the hundreds, and then the 0 in the tens, and the 0 in the ones. Same thing with the 420 here. 400, the 4 in the hundreds, the 2 in the tens, the 0 in the ones place, and so on and so forth. okay? Make sure, parents, if you want, have them draw out these lines in between to figure out if they have those numbers in the correct place value, okay? Because they need to align those numbers correctly. If they have this 4 in the thousands place, it's gonna be a complete different answer, okay? So here we go. This is 4, this is 4, this is 9 and 2, 11, carry a 1, and this is 4. So the answer here is 4,144, okay? This is using place value, the area model, okay? And I kind of try to combine them both so they could visualize, right? Now, this is one strategy that they could use. It takes longer, but it gives you the answer, it's more accurate in giving you the answer, okay? And it's easier to master. Now, let's go into standard algorithm. I'm gonna use the same problem here. 74 times 56, here we go. Now, for standard algorithm, you have to write or rewrite that multiplication problem, but vertically. To understand what I'm doing, 74 times 56, okay. So this is pretty much how I did it with the kids, okay? I color coordinated so they could know, okay, we're gonna multiply the 6 first, times the 4 and the 7, then add the 0 as step number 2, and then after step number 2 and adding that 0, we're gonna multiply the 5 times 4 and 5 times 7, okay? So we're gonna do that little by little, so here we go. So the first number, I always tell them, okay, if you wanna cross it out, cross it out. Cross 5 out, you know, just for now, okay? You gotta bring it back though, but we're gonna cross it out. Let's just do 6 times 4 first. 6 times 4, right? That is 24. Now, I had a lot of kids forget to carry over the 2 into the tens place. Carry over those 2 tens into the tens place, okay? Which is on top of the 7. A lot of students forget to do that and leave that 24 there, which gives you a complete different answer, okay? Another problem or the issue, they carry the 4 instead of the 2. So they would leave the 2 here and carry the 4, okay? That's also a mistake and it's gonna give you a complete different answer. So this is 24. The number in the tens place is the number that gets carried over, okay? And then we're gonna add that number to the product that we get from 6 times 7. So now, let's do 6 times 7. 6 times 7, okay, is 42, plus 2 is 44. Okay, now we have completely multiplied the 6 to the ones place and the 6 by the tens place. Okay, now let's do the 5 now. We gotta bring that 5 back, okay? Everything else that you did up here, you could erase it. And once you get better at it, you don't have to erase it because you would know what to do. But this is just small little things that you could do to keep you focused on the number. Okay. So we multiplied the 6. If you want to erase the 6, you can. You don't need to have it there. Okay, or just cross it out. Right. Now that I've erased the 6, I multiplied the 6 to the 4 and to the 7. I got my partial product, right, for that 6. The second step, and obviously I erased the 6, I erased the number that I don't need no more, okay? The second step is adding that 0, okay? I'm adding that 0 to the ones place. Okay, now I'm completely done with the ones place. So I'm adding the 0 in the ones place. That's the place that I just finished multiplying, okay, the 6. I am not multiplying that 6 no more. Okay, I'm moving on to the tens place that I'm multiplying, which is the 5, okay? So now I'm adding the 0, that's the second step, add the 0. First step, multiply the 6 times the 4, 6 times the 7. Second step, add the 0. Third step, to start multiplying the 5 times the 4. 5 times 4 is 20. Again, carry that 2. Don't leave it there. You have to carry it. If you don't carry, you're gonna get a complete different answer. Here you go. Now 5 times 7 is 35, plus 2 is 37. Okay? Now that I multiplied the tens place, the 5 in the tens place, times 4 and times 5, and then added the 2, now I'm gonna add my two partial products here. Okay? This is 4, this is 4, 11, carry the 1, 4,144. This is standard algorithm. This is how me and parents, this is how me and you kind of learned, and we were forced to learn, and we were forced to memorize. Well, this is how we used to learn it, standard algorithm. Now, there is another strategy that I wanted to show you guys where you could break it up, break this standard algorithm problem up, and then bring it together at the end. So here we go. I'm gonna show you that real quick. And this is actually kudos to Oriah, who has been working with me on this strategy, and she uses it a lot now. A lot, she uses it. And I'm proud of her. So here we go. And a lot of students use it too. Okay, not only her. All right, Sophia is another one. Here you go. So we're gonna break this standard algorithm problem up, right? We're gonna break it into two. We're gonna go this way and we're gonna go that way. Okay, let's just bring it up a little bit. Okay, so I'm gonna rewrite this problem, 74 times 6. Times 5, sorry. On this side, times 5. So 74 times 5. Then we have 74 times 6. Okay, so we kind of broke it apart. We took the 5 on this side, we took the 6 on this side, and then we have to put in a big 0 in the middle. Okay, so now I broke it up, and I'm just going to solve each one individually, which is why it makes it a little bit easier, because now we don't have to cross or crisscross or nothing like that. We could just multiply individually and then add it together. So here we go. This is 5 times 4 is 20. Carry the 2. 5 times 7 is 35. Plus 2 is 37. Now this is the tricky part. Once you finish the left side, you have to add that 0 to the answer, to the product of this left side only. Only the left side. You add that 0. Okay? So now, your answer is 3,700. Now let's go over here. Just multiply separately. We have 4 times 6, 24. Carry the 2. 6 times 7, 42. Plus 2 is 44. Okay? So now we have both our partial products. We're going to take these two products and we have to add them. Okay? Just different ways. There's so many ways to do math. Okay? Here we go. This is 4, 4, same thing, 4. It should give you 4,144. So this is just another way of doing it. Okay? There's other ways where you use the grid. Okay, grid paper, which would be, I'll show you. We have grid paper, right? So you would do the area model, right? Drawing the area model using these little square units, okay? But the thing is with the grid paper that if you obviously don't have 70 squares across and 5, then you're not gonna be able to use the grid paper, right? So, but this is just more of a visual, so they could see, they could visualize, okay, for example, we have 20 times 10, you would put 20 little cubes times 10 going down, and they could visually see. And they would probably need this later on when they do area. When they're figuring out area for a rectangle, this is what they would use, okay? But, so the grid, the multiplication of base 10 blocks, I'm gonna show you, base 10 blocks, utilizing these. So if I were to wanna make this problem here, this multiplication equation, I would take 7 of these 10s, right? 7 10s, right? 7 10s, 7, okay? 7 10s, and then I will have a 4 of the single cubes that are just singles, right? They're ones. These are 10s. The little cubes are ones. So I would have 7 10s, 4 ones, times 5 10s, and 6 ones. And it'll be the same thing. What you have to do is just add, or if you know how to count by 10, right? You'd have to count by 10, right? And you would visually see, okay, how many of the 74s do I need? 56. So you would see literally 56 of these 74s going down, right? And then they could visually see it. But again, it just takes a lot of time, we don't have a lot of cubes of these. So those are strategies that we, they use and they post just so they could visually see, okay? Visually see what they mean when it comes to their place values, right? The 10s, the 100s, the 1s. But when it comes to actual strategies to solve the multiplication equations, these are the good ones. These are the ones that I've been teaching. Now, apart from solving a multiplication equation, I just showed you three strategies, right? Apart from those 3 strategies, we also went over estimation, okay? So there's gonna be word problems in their tests or in the FAST test that are gonna ask them about figuring out about how much something equals to, right? So it's more of an estimation, more of an approximate, right? So they would look into words, keywords such as about, approximate, estimation. You're looking for those words, and automatically when you see estimation or when you see about how much or approximately how much would something or a person need, or how much, when you see those keywords, you would go to this strategy that I'm going to show you in a second, right? You would use compatible numbers, or you will go into rounding, okay? You could rather round an equation and then get an estimated amount, or you could use compatible numbers, turn those numbers into compatible numbers, and then get an estimation, a product that's estimated, okay? So here we go. Let's use the same problem here, okay? Now use compatible numbers. Let's just use compatible numbers for this one. Compatible numbers are, and I have it written up here. I don't know if you could see that. You could zoom in maybe. Okay, compatible numbers are numbers that end with a 0 or a 5. A 0 or a 5, okay? They're numbers that are easy to calculate, okay? If a number ends in a 0 and a 5, you could skip count by 5. If it ends in a 0, you know that you could use a zeros method. Just remove the 0, do the multiplication problem, add the 0 back. Or if you know how to count by 10s, then you count by 10s, right? The whole point here is to convert these two numbers, 74 and 56, into numbers that are easy to calculate. Easy to calculate and give you an estimation, all right? Not an exact, but an estimation. So when it comes to estimating numbers, or estimating greater numbers, you're estimating numbers to get an approximate number, not the exact number. The exact number, you would use those strategies that I showed you, okay? That would give you the exact product. But when it comes to estimating, or if you have a word problem, they're just asking you to give them about how much of something, then you would use rounding or compatible numbers. So compatible numbers. This 74. I know that compatible numbers rather end in 0 or 5. If I look at this 74, if I convert it into a compatible number, it would be 74, it would be a 75. Times, if I were to convert this 56 into a compatible number, it will be 55. 55, okay? These are compatible numbers, and then they would solve this going across. Now, I always tell them, okay, if this is what it's available, like let's say if this is A, B, C, or D, and they have, let's say for example, these are the examples that they have, right? They have, let's say 85 times 65 and 90 times 70, right? In this case, right, this is the closest one that it would be to be a compatible number, right? Because 80 can't be it, because if you round it, right, that 4 is telling the 7 to stay the same. Here, this is correct, right? You could convert that into a 60, but then it's wrong just because of the 80 here. The 85 is way too much for the 74, right? If you were to round or go up or down using compatible numbers, it will never give you 85. 65, again, too much of a number. Here, same thing, too much of a number, right? It's too much, it's not. You want to get as close to the exact as you can. It's not going to be the exact, but you want to get as close to it, right? Okay, so that's using compatible numbers ending in 5. Now you could convert these into zeros, right? And I always tell the kids, listen, try to make it as easy as you can for yourself, right? So you don't have to struggle too much. 74 could also be a 70, right? That's a compatible number. 50 could go up to 60. That is also a compatible number, right? So our original answer, or exact answer, is 4,144, but they want an approximate or about, right? So it would be 4,200 for this one, right? If you solve it, going across, again, taking the zeros out, solving the fact here, 7 times 6, which is 42, putting the zeros back on. This is an approximate, right? Okay, so if let's say you're counting people in a stadium, right, in a baseball park, and you pretty much don't know how many people are going to be available or going to be there, and then you just want a ballpark, you're going to say, okay, I know that there's probably, I don't know, 4,144 tickets sold so far, but let's just go up to about 4,200, and we expect about 4,200 people to arrive, right? So this is just an about, right? Where this is exact, and this is about using compatible numbers. Now, rounding. Rounding still seems to be as crazy as it sounds. It's still a little bit of a struggle for them to round, okay? So if I'm rounding this 74, I'm looking at the 7. This is my starting number. That's my rounding number. My rounding number is going to look to the number to its right. So it's right. It's going to say, hey, listen, do I go up or do I go down? It seems like where they get stuck at is the rule of from 0 to 4, it stays the same. From 5 to 9, it goes up. That's where they get stuck at. So, but if they keep practicing this, they'll get it. The 7 is going to look at the 4. The 4 is telling the 7, hey, listen, stay the same. We're not going up. So this 74 turns into a 7 because it stays the same, and everything else turns into a 0. So that gets rounded to 70, right, to the nearest 10, because this is a number that's a tens, right? This is a tens number. There's no hundreds here. So we're always rounding to the nearest tens, depending on the number. So right here, this is a tens number, right? It goes up to the tens, and we're rounding to the nearest 10. So this 74 turns into a 70. Now, 56. The 5, right, is looking at the 6. The 6 is telling the 5 to what? To go up. To go up one, right? Okay? And we're just going to go up. This 5 turns into a 6. 6 turns into a 0. Again, we get 4,200. That's rounding. So using compatible numbers, right? Compatible numbers is pretty much you look at the number, you gauge it between two numbers. Which one is it closer to? If it's closer to 75 or to 70, then you select that number. Rounding is literally what it is. It's rounding. You're rounding the number to the nearest 10, and then you get your compatible number or numbers that end in 0. Okay, and that's pretty much it. Now this, again, this is completely separate from what the strategies that I showed you. Okay, the strategies that I showed you is to get an exact product. Okay, you're multiplying and you're getting an exact product. Now there's going to be questions in the test and in the quiz that are going to tell you to estimate. All right, to estimate a product or estimate or choose the appropriate estimated equation. Okay, and those are key words that they need to look for. Okay, about, approximate, even estimation or estimate. That's just keywords that they're looking for to know, okay, I need to round, or I could use compatible numbers in this problem. Okay, so that's pretty much it. Now, going to further into topic 4. Topic 4 is huge. Topic 4 is big. They're gonna go into now multiplying 3-digit numbers times 2-digit numbers into topic. This would be lesson 9. They're gonna go into that, which would be multiplying 3-digit numbers times 2-digit, 3 times 3. But this is kind of simple because in here, again, you take out your zeros. I know I took out 4 zeros. Let's say for this problem here, I took out 4 zeros. I'm multiplying 5 times 1, which is 5, and I'm adding the 4 zeros again, okay? This is using the place value, okay? The value of those numbers, right? So, and then, let's see, what else? Let's see. Estimating. So they're going to give them, okay, and they have to read. It says estimate each product, okay? Be ready to explain your method, okay? And they have to take the 38. And for example, in this one, 38, you could use round or compatible numbers. It would be a 40. Here, you would probably, you know, if it's 128, you could put 120 or 130, okay, and then multiply those two. All right. So that's what we're going to be going into in the next few weeks, and then I believe we should be testing on the 24th of this month. So we'll see. We'll see how it goes. We'll see how they do just adding that extra digit, right? If I add that extra digit, it's just an extra step. The area model is a bit more bigger, and we'll go over that. But if you have any questions, guys, let me know. I'm here. Shoot me a text. I'll see you in the following days, guys. All right, bye.